Everyone, welcome back to our channel. Today we are going to discuss about combination of resistances. Here we are going to discuss there are two types of combinations. One is the series combination of resistances, another one is the parallel combination of resistances. In our daily life, for electronic devices, for controlling the electric current, we are using these combination of resistances. First of all, we are going to discuss about what is the resistances in series combination. For this, we are taking, this is the R1. Second end of first one is connected to first end of second resistor. Then second end of second resistor is giving to first end of third resistor. So this type of combination is called the series combination. Second end of first one is giving to the first one of second resistances. And second end of second one is giving to the first end of third one. Second end of third one is giving to the first end of fourth one. Then what are the remaining two terminals? First end of first resistance and second end of last resistance is connected to a battery. It has two terminals. One is at high potential, another one is at low potential. Then in series combination, we must remember that potential is variable. Here potential is variable, but current is constant. Here the current passing through the circuit is I. Across the R1 also current is I, and across R2 is also current is I. Across R3 is also current I. Across R4 is also current I. But we should observe across the battery the potential is V. Across the R1 V1, and this is V2. From this is V3 and this is V4. From Ohm's law, we know that V equals to IR. This is across the battery potential, total current, and combination of this resistors, equivalent resistance. V1 equals to IR1. V2 equals to IR2. V3 equals to IR3. V4 equals to IR4. Then V equals to V1 plus V2 plus V3 plus V4. In all these, instead of V, we are writing IR. Instead of V1, IR1, IR2, IR3, IR4 like that. So we are taking I is common. R1 plus R2 plus R3 plus R4. So here I and I is cancelled. Equivalent resistance in this combination is R equals to R1 plus R2 plus R3 plus R4. Suppose we are taking n number of identical resistors. What is the effective resistance? N times of that R, because R plus it is repeating n times. So RE equals to, in this case, NR. How the potential is dividing? Suppose in our problems we know the current and individual resistances. How to find out the potential across the individual resistors? So from this we know that R equals to R1 plus R2 plus R3 from this. Then how to find out the current here? I equals to V by R. I equals to V by R. So instead of R, we are writing V by R1 plus R2 plus R3 plus R4. Because we are using the 4 resistances, this one. Then what is the potential across the first resistance? V1 equals to, from Ohm's law, I into R1. I into R1. But instead of I, this is constant. V by R1 plus R2 plus R3 plus R4. This is instead of current. But we want potential across R1 means we are getting R1. Similarly, across V2 we should write it I R2 V by R1 plus R2 plus R3 plus R4. This is across R2 means we are taking R2. So we can find out the individual potentials across the resistances, and we are going to discuss one problem also here. We are taking two resistors. First one is R1, this value is 4 ohms. Second one is R2, this value is 2 ohms. And across this we are taking one battery connection. This potential is, we are taking 2 volts. First of all, what is the equivalent resistance? Clearly there is no division of the current, so this is the series combination. And potential, we know that effective resistance is R1 plus R2. So this is the 6 ohms. Potential is 2 volts. Then how to find out the current? I equals to V by effective resistance. V by 6 equals to 1 by 3 amperes. So across the R1 current is 1 by 3 amperes. Across the R2 current is also 1 by 3 amperes. But how to find out the individual potential in this case? V1 equals to, use this formula, I into R1. I into R1. I is the 1 by 3. Here R1 is the 4 ohms. So 4 by 3 volts. Like that. Across the R2, what is the potential? V2 equals to I into R2. So 1 by 3. Here R2 is 2. So 2 by 3 volts. From the given data, that to series combination of resistances, we can find out the individual potentials. We can find out the effective resistances based on the number of resistors. The resistances in parallel combination. How we are giving the parallel combination? We are taking 3 resistors. First one resistance is R1. Second one resistance is R2. Then third resistance is R3. All first ends we are giving one terminal of the battery, and all second ends we are giving another terminal of the battery. Here we should consider potential is V. How much current is passing through the circuit? I. But in this case, I is dividing across R1, R2 and R3. But in parallel combination of resistances, which is constant here potential V is constant, but I is variable, current is variable. From Ohm's law, we know that current, what is the formula? I equals to V by effective resistance. Like that, I1 equals to, we are writing V by R1, I2 equals to V by R2, because potential is constant in parallel combination. I3 equals to V by R3. Then how to find out the effective resistances? In this case, we can go through the once again Ohm's law. I equals to, here I is dividing into 3 parts. I equals to I1 plus I2 plus I3. Instead of I, we are writing V by effective resistance equals to, here also potential is constant, within brackets 1 by R1 plus 1 by R2 plus 1 by R3. This one cancel. Finally, we are getting 1 by R effective resistance equals to 1 by R1 plus 1 by R2 plus 1 by R3. So, when we are using 3 resistors in parallel combination, we are getting 1 by R1 plus 1 by R2 plus 1 by R3. Then we are going through the combination of 2 resistors. Suppose we are taking 2 resistors, one is the R1, another one is the R2. Both are connected in parallel. Across this, potential is V. Here, how to find out the effective resistance? We are getting 1 by R effective equals to 1 by R1 plus 1 by R2. When we are taking the LCM, R effective resistance equals to, we are getting R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Suppose we are giving this is the 3 ohms and this is the 5 ohms and this is the 2 volts. Then how to find out the effective resistance? Here R effective equals to, direct we can use R1 R2 by R1 plus R2. So 3 into 5 by 8, 15 by 8 ohms. This is the effective resistance. Based on this, we can find out the current also. Current across the first resistor I1 equals to V by R1. Already we know that V equals to 2 volts. Then R1 equals to 3 amperes. Like that, I2 equals to V by R2. V is the 2 volts, R2 is the 5. This unit is amperes. So when we know the potential and the resistances, we can able to find out the effective resistance across entire circuit. At the same time, individual current also we can able to find out. Here potential is constant. And one more thing, if n number of identical resistors connected in parallel, at that time, what is effective resistance? We can take it 1 by Re equals to 1 by R plus 1 by R plus and so on 1 by R. It is repeating n times. This is n by R we are taking. Here effective resistance equals to R by N. When we are taking the series combination, how much we know that? N into R. When we go through the comparison, where we should get the more resistance in series combination, it is n times of R, but this is the R by N. When we are going through the division of this one, Rs by Re, means first all resistors we are connected in series. What we are getting, that effective resistance NR. Then one more thing, combination we are taking, parallel combination of resistance, that is R by N. So here RR cancel, you are getting that value is N square by N. From this, what you are understanding, when we are going through the division of series and parallel combination, identical resistors, that one is you are getting N square by N. If we are taking 10 resistors in series combination, identical resistors, then 10 resistors are connected in parallel. At that time, what is the ratio of series to parallel combination? N square by 1. Instead of N, we are using the 10 square by 1 we are getting. That answer is 100:1. Thank you.